In this video, we're going to talk about how do you recognize the precision of a quantity, in particular one that you didn't measure. In one of the earlier videos I just showed you we went over how do you measure, and remember the goal, maybe not in reality, but in theory, is to push your measuring device to its limit, which means you would record all digits that you know for certain, plus one more that represents a reasonable estimate. But now suppose that someone hands you a measurement and you're asked to interpret, well, how precise was this measurement? For example, suppose that somebody just told you, hey, I measured the distance between my dog's ears, and this is going to be a pretty big dog, I guess, because one of them, in one measurement, she says the distance is 2 meters. Okay, it's a big dog. Another person measures their dog ears, the distance between their dog's ears, and it's 2.00 meters. Now, both of these are the same length. But there is an absolutely fundamental difference between writing down 2 meters and writing down 2.00 meters. So that's the goal in this discussion, is to have you recognize, okay, why is 2.00 much more precise than 2 meters? And I think an example would be helpful. I just found this one on the internet. And let's see what it says before we get into it. The precision of a measurement depends on the instrument that was used to measure it. So let's go ahead. This is a nice little mini review. So let's use the ruler on the left to measure this block, and I can see that, okay, let's do this, that I know that it's more than 1 and it's less than 2, so I'm going to write down 1, and it's going to be in inches. We'll write that later. And that one, I'm certain of it. So should I stop? No, you keep going. The next one, because there's no more tick marks, is going to be an estimate. Not a guess, but an estimate. And so I'm going to say that it's 1.5. It is going to be inches. And now, should I keep going? No, because that was an estimate. And you only estimate that one additional digit, and then you stop. So I'm going to say that this block is 1.5 inches. But now let's use this guy. And now we can say, okay, I know that it's more than 1 and less than 2. And then now if we zoom in, we can see that the next one is the 10th digit, and that's going to be 1, 2, 3, 4. So I know that it's less than 4 and more than 4 and less than 5. So so this is, I'm certain of this and I'm certain of that. Do I stop? No, you keep going, because you have to keep going until that last digit is an estimate. So now I'm going to look in and I'm going to just say, okay, it looks to me about half. Well, I don't want to, it looks to me about like 5. So I'm going to say that, and that is my estimate. So now I stop. So that block is 1.45 inches. Okay, do you see the difference? This guy is more precise. This measurement to the right is more precise than the one on the left, because you used a more precise measuring device. So this guy, the guy on the left, has 2 significant digits or figures, and this one has 3. And so the general rule is that the more significant figures in a measurement, the more precise your measurement will be, the more dialed in it will be. Let's see what the precision would be. Let's see what so another way of saying more precise is to say less uncertain. They're kind of the same thing. The less uncertain you are, the more precise. So what is the uncertainty? What is the uncertainty of this 1.5 inch measurement? Well, it turns out if you go back, Sorry about that. It turns out that basically the uncertainty is plus or minus half of whatever your estimate was. So our estimate was in the tenths place. This is really, I'll say this is just background, okay? You don't have to, this is not, so, all right. So the uncertainty is plus or minus half of a tenth. So it's going to be plus or minus 0.05 inches. This is, again, this is not something, this is not something you need to know about. It's just to give you an understanding. So what I'm saying basically is that this measurement with the ruler on the left could have been anywhere between, the uncertainty is plus or minus 0.05 inches. So the total uncertainty plus or minus in either direction is actually 0.1 inch. So this thing could have been anywhere between 1.545 inches and 1.55 inches. So this has an uncertainty of 0.1 inches. Okay. Now we're going to look at the measurement made by the ruler on the right, and that was 1.45 inches. Now, what was its uncertainty? Well, if you look here, we actually were estimating, so we knew to the nearest tenth, we were certain about the tenths column, and our estimate had to do with the hundredths column. So, oh my goodness, I got to figure out what I'm sorry about that. We had to, we were estimating in the hundredths column, so our uncertainty was plus or minus not 0.05, but 0.005 inches. So that means our measurement here with the second ruler could have been anything between 1.445 inches. Again, if I'm losing you, this is just background to make you appreciate, why is it that more significant figures means more precise? Okay, so this thing could have been anywhere between 1.445 inches and up to about 1.455 inches. Okay, so what is the uncertainty of that? The uncertainty is 0.01 inches. So instead of being an uncertainty of a tenth of an inch, it has an uncertainty of only a 100th of an inch. So this is 10 times as precise. Okay, this was background. The key thing you need to know is that what I really want you to take away is that more significant figures in a quantity means more precise. That there is an absolutely fundamental difference between saying something is 2 meters long and 2.0 meters. This is 10 times as precise. And saying something is 2.00 meters long is 100 times more precise. Now you can't just write these down. You have to have the measuring device that allows you to say something is 2.00 meters long. Please don't think I'm saying, oh, just add more zeros and your measurement will be more precise. No, you have to get a more expensive measuring device. Okay, so that's the idea. I think I'm going to stop the video here because I'm too late to get in the rules. But the absolute key point is the reason we are going to learn about how do we determine significant figures is because it tells us the precision of a quantity. And the next video we'll talk about, well, what are the rules? How do I determine what is significant in a quantity that's just handed to me about the length between two dogs' ears?